This is part 2 of your refresher on factoring. Factoring when a isn't 1. So first, what does that mean? Well, what is a quadratic expression? That's when you have something like ax squared plus bx plus c. A, b, and c are just going to be numbers. We already dealt with when a was 1, so there wasn't really a number in front of x squared, and if a was the GCF of a, b, and c, so I could factor that number out. Now we're going to deal with when a is a prime number. And in the next video, we'll deal with when a is not prime or the GCF and how to deal with that. So we have 3x squared minus 10x plus 3. This is not quite as simple as saying what numbers multiply to 3 and add to negative 10, because that doesn't exist. We have to think about how can I break apart 3x squared? Well, I make my two sets of parentheses, and the only way to break apart 3x squared is 3x and 1x. Then we think about what numbers multiply to 3. Lucky for us, the only options are 1 times 3. So we have to decide if it's going to be a 1 and 3 or a 3 and 1. And this is where guess and check comes in. The guess and check method, we don't have to check, well, we don't have to check the whole thing. We're essentially foiling it out, but we don't have to check the first because 3x times x makes 3x squared, and we know that. We don't have to check the last because 1 times 3 makes 3, and that's why I chose those numbers. We just have to check the inside two pieces, the outside and inside. So I need to check here and here because those two pieces should make my negative 10x. Well, 1 times x makes 1x. 3x times 3 makes 9x. Is it possible for me to make a negative 10x with those? Well, yeah, if they're both minuses, so I can put both minuses. Notice that if I check the other one, because I just happen to get lucky and choose my placement right first, I'd have 3x and 3x. There's no way for me to get a 10x out of that, so that is not correct. My final answer is 3x minus 1 times x minus 3. I can FOIL it out to double check. Remember, you could also have x minus 3 times 3x minus 1, but you cannot flip-flop where if the 1 goes with the 3 or the 1, all right? If you like tricks and shortcuts, there are plenty of those out there. You are welcome to find one using Google. I will not teach you any of those, and I do not use them, so I cannot help you. If you try to use a trick, you're on your own. So let's keep going. Some more examples. 7k squared plus 64k minus 60. Always check for a GCF first. 7, 64, and 60 don't have any factors in common. We have to dive straight in. The only way to break apart 7k squared is 7k and 1k. So now we need numbers that multiply to 60. We have 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. And that's it. That's a lot of options to try. So now I just have to guess and check and hope I get lucky. Worst case scenario, I go through all my options. So let's say I tried 1 and 60 first. Well, when I check my inside, I have 1k, and my outside is 420k. And there's absolutely no way that's going to make a 64k. But anytime you're guessing checking, make sure you flip-flop it. No, that's not right. Make sure you flip-flop where those 60 and the 1 go. Here I get 60k and 7k. Ooh, that's close to 64, but it's 67. That's not my right answer. So that means I ruled out 1 and 60. So I just have to keep trying. And sometimes you start to see patterns and find a way that'll work a little bit better. But also notice here that this 60 was minus 60, which means one of these two numbers, when I use it, has to be a minus. And my numbers have to add to positive 64. So be very careful of your signs. So let's see. I think I'm going to try 6 and 10. 6 times k is 6k. 7k times 10 is 70k. Well, if I have a positive 70 minus 6, I get 64. So to get a positive 70, I need my 10 to be a positive. And to get a negative 6, I need my 6 to be a negative. So my final answer is 7k minus 6 times k plus 10. For 5n squared minus 2n minus 16, the only way to break apart 5n squared is 5n and n. 16 could be 1 times 16, 2 times 8, or 4 times 4. And I need to make a minus 2 in the middle. Remember that this is a minus 16, so one of my numbers here will have to be a minus. Let's see, let's try 2 and 8. Well, here I get 2n and 40n, and there is no way I'm making the 2n in the middle with a 2 and a 40. But never give up on it until you've tried both directions. So 8 and 2. 8 times n is 8n. 5n times 2 is 10n. Well, if I make that negative 10 and positive 8, I get that negative 2. So that means the minus has to go with the 2 plus with the 8. My final answer is 5n plus 8 times n minus 2. All right, for 3r squared minus r, always, always, always remember to check for GCF first. I forgot to remind you on that last one, but always look for GCF first. I can take an r out of both of my terms. So if I take an r out of 3r squared, I'm left with 3r. If I take an r out of minus r, remember there's that invisible 1 in front of it, so it's just a minus 1. And that's all I can do. That is factored. Don't overthink it. Don't try to go further than you need to. R times 3r minus 1, done. All right, next up we have 8b squared plus 60b minus 200. Well, I know all three of those numbers are even, so I know there must be a GCF. And actually, it's not just 2, it is 4. So I can take a 4 out of each of those terms. So I'm left with 2b squared plus 15b minus 50. All right, now remember this 4, your GCF comes along for the ride. But we just have to factor 2b squared plus 15b minus 50. The only way to break apart 2b squared is 2b and b. Numbers that multiply to 50, I have 1 and 50, 2 and 25, 5 and 10. That's it. So I think about what can make my plus 15. Remember that this is a minus 50, so one of these numbers has to be a minus. I think 5 and 10. If I do 5 and 10, check the inside, I have 5b. Outside, I have 20b. To make a plus 15, I can go positive 20 minus 5. Perfect, that means my 10 gets a plus, my 5 gets a minus. My final answer is 4 times 2b minus 5 times b plus 10. For 28x to the 5th minus 248x to the 4th minus 36x cubed. Well, we've never dealt with x to the 5th powers before. We don't know how to factor those. But look for your GCF first. Well, 28, 248, and 36, all of those can at least be divided by 4. And I noticed that I can take x cubed out of all three terms also. So my GCF is 4x cubed. That leaves me with 7x squared minus 62x minus 9. Give it another check. Can anything go into 7, 62, and 9? It can't, so that's my GCF for sure. Now I factor the rest. So I have 4x cubed hanging out front. The only way to break apart 7x squared is 7x and x. Numbers that multiply to 9 are just 1 and 9 or 3 and 3. So I choose what I think is most likely. I'm going to try 3 and 3. Inside makes 3x. Outside makes 21x. There's no way for me to make that a 62. That's not right. So back to this. Well, I can't flip-flop the 3 and the 3, so it's not 3 and 3. It must be 1 and 9. So I try 1 and 9, and if that doesn't work, I flip-flop the 1 and 9. 1 times x is x. 7x times 9 is 63x. Well, to make minus 62, I need negative 63 and positive 1. So the 1 gets a plus, the 9 gets a minus. My final answer is 4x cubed times 7x plus 1 times x minus 9. 6z squared minus 21z. Always look for a GCF first. Well, I noticed they can both be divided by 3. And they both have a z. If I take 3z out of 6z squared, I'm left with 2z. And if I take 3z out of 21z, I'm left with the minus 7. And look at that, it's factored. There's no more variable squared. I can't factor any further. That's done. And 4x squared minus 2x minus 2. Look for a GCF. I can take a 2 out of everything. It leaves me 2x squared minus x minus 1. My 2's along for the ride. The only way to break apart 2x squared is 2x and x. Lucky for me, the only way to multiply to 1 is 1 and 1. Check my inside, I get 1x. My outside, I get 2x. To make a minus x, I need my 2x to be negative, my 1x to be positive. So I put a plus with my 1, a minus with my other 1. So our answer is 2 times 2x plus 1 times x minus 1. Remember that to double check these, you can always just multiply it back out and make sure you got what you started with. All right, so a few more examples here, well, 10 of them. I'm going to go through kind of quickly. All right, first one, 10n squared plus 114n plus 140. I'm going to start with the GCF. I know they're all even, so I'm going to take out a 2. That leaves me with 5n squared plus 57n plus 70. Well, now I know I can break apart 5n squared into 5n and n. I need two numbers that multiply to 70. My brain goes straight to 7 and 10. If I check the inside, I get 7n. The outside, I get 50n. Add those together, so they're both positives, to make 57n in the middle. For number 2, there is no GCF on this one, so we dive straight in. The only way to break apart 5x squared is 5x and x. Numbers that multiply to 54, I like 6 and 9, because 5 times 9 makes 45. Minus 6 would make 39, so positive 45, negative 6. There we go. Third one, I see a GCF there. My GCF here is actually 6. So if I take 6 out of everything, I get 5x squared plus 4x minus 9. So my 6 is along for the ride. To break apart 5x squared, I have 5x and x. Things that multiply to 9, I have 9 and 1, or 3 and 3. I think it's going to be 9 and 1, because I'd get a positive 9 minus 5 to make that positive 4. For number 4, we do not have a GCF, so we dive straight in. We have 7n and n. Numbers that multiply to 30, I have 1 and 30. I don't think that'll work. 2 and 15, I don't think that'll work. 3 and 10, I do think, because 3 times 7 is 21, and 10 makes 11. So positive 21 minus 10 leaves me with 11. For number 5, I've definitely got a GCF here. My GCF is 6 again. That leaves me 5a squared minus 38a minus 63. And to break apart 5a squared, I have 5a and a. All right, numbers that multiply to 63, I have 1 and 63. I don't think that'll work. I have 3 and 21. Well, 21 and 15. Nope, that's not going to make my 38 in the middle. I have 7 and 9, which is my last option. So it's definitely going to be 7 and 9. I'm going to go with 7 and 9 because 9 times 5a makes 45a. So I want that negative. 45 plus 7 makes negative 38. All right, for number 6, dive straight in because there's no GCF. 3k and k. Numbers that multiply to 40, 1 and 40. I don't think that'll work. 2 and 20. Ooh, 2 and 20 seems promising, but be careful. Because if I go 2 and 20, I get 20k and 6k, which makes 26k. But the problem is, to make a negative 40, one of these has to be negative and the other has to be positive. So 20 and 2 doesn't actually work. So it's not 20 and 2. How about 4 and 10? Well, if I do 3k times 10, I get 30k. 30 minus 4 makes 26. So to make it negative, negative 30 plus 4. So be very careful of your signs here. For number 7, there's no GCF, so I dive straight in. I break it apart into 3n and n. This is a positive 42, so I know they're the same sign. A minus 25 means they're both going to be minuses. All right, numbers that multiply to 42. 1 and 42. I don't think that'll work. 2 and 21. Not going to work. 3 and 14. Also don't think that'll work. 6 and 7. 6 and 7 must be it. Well, 3 times 6 is 18. 18 plus 7 makes 25. So there's my answer. For number 8, we definitely have a GCF here. I'm going to take a 5 out of everything. That leaves me 3v squared minus 25v plus 50. And then we do our second step of factoring. My 5 hangs out front. 3v squared breaks apart into 3v and v. Numbers that multiply to 50, and then my inside and outside make 25. Well, I don't want 1 and 50. I don't think 2 and 25 will work. Let's try 5 and 10. Here I have to be careful though. I need the 10 here and the 5 here because since this is a plus, they have to be the same sign. So I need 10v and 15v to make 25v. Both of them are minuses. And number 9, my GCF here is 6. Leaves me with 5m squared plus 43m minus 70. Only way to break apart 5m squared is 5m and m. Well, numbers that multiply to 70, I like 7 and 10 because I know 50 minus 7 is 43. Positive 50 minus 7. There we go. And 14m squared minus 2m minus 16, I see a GCF of 2, making it 7m squared minus 1m minus 8. My 2's along for the ride. The only way to break apart 7m squared is 7m and m. 8, I can do 1 and 8 or 2 and 4. But to make a 1 in the middle, I definitely need to do 8 and 1 because negative 8m plus 7m makes that minus m in the middle.